For thousands of years, Betelgeuse has stared back at us from Orion's shoulder, a blazing red sentinel anchoring our winter sky, massive, unstable, impossibly distant, yet always present, a cosmic time bomb, ticking down with a brightness that dares you to look away. For decades, astronomers watched and waited. They knew what was coming, or thought they did. But they weren't ready. No one was. Because what the James Webb Space Telescope just revealed changes everything. Betelgeuse has exploded. The closest supernova ever observed. A titanic release of energy and matter, just 642 light-years from Earth. But the real shock isn't the explosion itself. It's what the explosion isn't. This wasn't a clean collapse. This wasn't a standard model, a textbook case of stellar death. What JWST captured wasn't just the final breath of a dying star. It was a contradiction wrapped in fire, a celestial paradox, a cosmic betrayal of every equation we thought we could trust. Because Betelgeuse didn't just die, it transformed. And what it's becoming may be something we've never seen before. If you're still watching, subscribe now. You crave more than answers. You seek what lies beyond. Subscribe now and be part of the few who never stop searching. For years, scientists debated Betelgeuse's fate. Red supergiants, by their very nature, are doomed to die young. They live fast, burn bright, and collapse under their own weight. The physics is brutal and simple. When the nuclear furnace runs out of fuel, when iron builds up in the core and fusion halts, the star collapses in milliseconds. Then comes the supernova. Core rebound. Outer layers blasted into space. What's left behind is either a neutron star or a black hole. That's the script. But what JWST saw doesn't follow the script. Infrared readings showed massive surface convulsions before the explosion. Convective bubbles the size of Jupiter rising, bursting, vanishing. Magnetic fields tangling and unraveling in real time. Energy bleeding from the core, not uniformly, but directionally, like something inside was trying to escape, not implode. And when the shockwave came, it wasn't symmetrical. It wasn't even centered. Plasma erupted in lopsided jets, not the balanced shell expected from a star this massive. Plumes of matter, some moving slower than predicted, some faster. Chunks of the core appearing to resist collapse entirely, ricocheting outward in bursts that defied gravity and symmetry. And in the center of it all, a void. Not a clean neutron star, not a black hole signature, but a gap, a cold zone, a magnetic shadow where matter should have been. Something was missing, something we can't explain. The first theories were cautious. Maybe it was a rotational anomaly. Maybe Betelgeuse was spinning faster than expected. Or maybe the magnetic fields played a larger role than we thought. But as JWST pulled deeper scans, layer by layer, shell by shell, the inconsistencies piled up. Carbon and oxygen were there, as expected. So were heavier elements, like yttrium and technetium, evidence of nucleosynthesis, the alchemy of star death. But the patterns were wrong. The distribution was wrong. Instead of spreading evenly through the ejector, these elements clustered in strands, threads, filaments, as if something had woven them, as if the explosion was organized. This wasn't chaos. This wasn't random collapse. This was patterned behavior in the death of a star, a structure inside destruction. And that structure, it shouldn't exist. The next anomaly came from the interstellar shock. As the supernova shockwave expanded outward, it slammed into surrounding gas and dust. That's normal. What's not normal is what happened next. The dust didn't just glow, it reconfigured. Filaments compressed, cloud structures twisted into spirals. Some even began emitting polarized light, an indicator of highly ordered magnetic realignment. Scientists watching in real time saw entire regions of the interstellar medium bend and shift in response to the wave. It was like watching an invisible hand sculpt a nebula. But that's impossible. Supernovae are explosions, not instructions. They don't build, they destroy. And yet Betelgeuse's blast wave didn't just erase, it reshaped. And whatever force was guiding that shaping, it was coherent. Then came the pulse. Days after the initial explosion, JWST registered a ripple in spacetime. Not metaphorically, literally. A gravitational wave, faint but traceable, emanated from the heart of Betelgeuse's collapse. Gravitational waves typically come from neutron star mergers or black hole collisions. They require movement of enormous mass through violent accelerations. But this wave wasn't consistent with a collision. It was oscillating. A pulse, a beat. Like something inside Betelgeuse didn't just collapse, it contracted and stabilized, then pulsed outward like a beacon. One wave, then another, then silence, as if something inside had turned on or awakened. And that's when the whispers started. What if this wasn't the end of a star? What if it was the birth of something else? Not a neutron star, not a black hole, not a quark soup or exotic matter collapse. Something in between. A transitional object, a stabilized anomaly, a hybrid core held in place by something more than gravity, more than fusion, more than any force we've catalogued. The equations don't predict it. But Betelgeuse doesn't care about equations, because what's left behind in the heart of that star may not be definable at all. It could be a new state of matter, a new class of celestial object, a phenomenon we don't even have a name for. Yet, and here's the part no one wants to say out loud, what if this wasn't natural? What if Betelgeuse didn't just die? What if it was triggered? Because the timing is suspicious. The structure is suspicious. The symmetry or lack of it is suspicious. Nothing about this explosion fits the standard profile. And if the laws of physics were violated, then who or what broke them? That's the question behind closed doors. In labs, in observatories, in quiet conference calls with redacted transcripts. Because the idea that we just watched a new kind of object form in our own galactic backyard isn't just exciting, it's terrifying. Because if it happened once, it can happen again. And if it wasn't natural, it might happen on purpose. But let's stay grounded. Let's assume Betelgeuse was just an extraordinary anomaly. Even that conservative scenario shatters our understanding of star death. It redefines the timeline of collapse. It challenges the assumptions of fusion, entropy, and matter density under extreme gravitational strain. It alters how we interpret spectral data from distant galaxies, and it forces us to reconsider the boundary between life and death in stars, not as a binary but as a spectrum, a continuum. And somewhere in that spectrum, Betelgeuse sits defying labels, changing everything. There's no threat to Earth, not yet. The radiation won't reach us. The particles will dissipate. But the light is already here, and it's not just bright, it's different. Astronomers report unusual lensing effects, background stars warping slightly, signals taking longer routes to reach us, as if the explosion didn't just reshape matter, it bent the medium itself, as if space-time has been scarred. Betelgeuse's death echo may linger not in energy, but in the shape of the cosmos. And that, more than anything, demands attention. Because the story of Betelgeuse isn't over. It's just beginning. This was supposed to be a spectacle, a fireworks show, a scientific jackpot. Instead, we got a mystery. A real-time, high-resolution, data-rich mystery that doesn't just challenge science, it dares it to evolve, to adapt, to let go of old models, and face a cosmos that isn't passive but reactive. Because if JWST has shown us anything, it's that the universe is still capable of surprise. It's still wild, still untamed, still far beyond the reach of our certainty. And somewhere out there, in the hushed debris of a broken giant, something waits. A pulse, a shadow, a question we weren't ready to ask. Because Betelgeuse didn't just explode, it changed form. And the form it's becoming is not what we were told. You look at the sky and you think you understand it. Pinpricks of light, fixed patterns, ages-old myths pinned to constellations. We gave Betelgeuse a name, a story, a role to play, the proud shoulder of Orion, a star with personality, a star nearing the end. But what if it wasn't just dying? What if what the James Webb Space Telescope just revealed is more than a phase in the stellar life cycle? What if we're witnessing not a finale, but a transformation so rare, so extreme, it breaks our classification systems altogether? Betelgeuse did what red supergiants are supposed to do, right up to the point where it didn't. It flared, it flickered, it dimmed unpredictably for months, a behavior that sparked speculation. But even in our boldest models, we didn't expect this. Not the complexity, not the structure, not the contradictions stitched into every infrared frame, every magnetic anomaly, every gravitational pulse. Because what JWST has found, what scientists can now examine with ruthless clarity, is something we were never meant to see so close. Not just a supernova, but a process far stranger. A cosmic revision in real time. Let's get something straight. Supernovae are supposed to be violent. Yes, but predictable. They obey equations. Pressure balances. Energy out. Gravity in. The endgame of mass and fusion. But Betelgeuse isn't obeying. JWST recorded oscillations in the core before collapse. Waves of pressure that stalled the core's implosion. Something interfered. Something delayed the moment of death by fractions of a second. But in astrophysical terms, that's an eternity. A sliver of time enough to change everything. That delay, that hesitation, caused matter to redistribute. It caused fallback. It caused lopsided shockwaves. Not random, but structured asymmetry. The explosion didn't just happen. It was shaped. And then came the light, thousands of times brighter than the full moon, flooding detectors with information. In that blinding rush, JWST picked up something truly wild, pulsed infrared bursts layered into the supernova glow. Not steady emissions, not flickers, but beats. Intervals between pulses were almost but not quite uniform. Like a frequency trying to regulate itself. Like a signal. That word's dangerous, of course. Signal. It invites interpretation. It evokes intent. But here's the raw, uncomfortable truth. This wasn't noise. These bursts matched no known natural supernova artifact. They weren't thermal echoes. They weren't rotational wobble. They were something else. Consistent. Coordinated. Rising and fading like breath in the dark. Meanwhile, the core collapse, normally the central drama of any supernova, left behind no confirmed remnant. That's the big problem. It should have been one or the other. Either a neutron star, a city-sized sphere of atomic density, spinning fast and emitting radiation like a lighthouse, or a black hole, invisible, but with a gravitational signature, something you can measure by its effects on space. But Betelgeuse left neither. Instead, it left a thermal shadow, cold, magnetically unstable, and emitting low-frequency gravitational oscillations. A cavity, a center that pulses but doesn't spin, emits but doesn't radiate. Like something just paused inside it. There are no words for that. We have terms like proto-black hole, or quark star, or failed supernova remnant, but they're hand-waving at a mystery. None fit the data. This thing isn't failing. It's functioning. But it's not behaving like a remnant. It's behaving like a process, a system. So now the theoretical physicists come crawling out. They've got names. Graviton echo chamber, anisotropic stellar loop, quantum collapse window. Big words, big formulas. But behind all the jargon is one central silent question. Did we just see a star turn into something new? Because in science, one anomaly is a fluke. But this isn't a flicker on a screen. This is a full-spectrum, real-time observation with multiple corroborating instruments. Betelgeuse didn't just collapse, it reorganized. It didn't just explode, it reshaped the space around it. The dust cloud tells the story. In the wake of the blast, instead of diffuse radiation and free-floating debris, we see sculpted filaments, dust compressed into lattices, plasma flowing along magnetic highways, not tumbling aimlessly. There's order in the aftermath. Too much of it. Some of the dust is even reflecting its own light, due to high polarization values, something unheard of in supernova remnants at this proximity. It's like we're seeing a feedback loop between the material ejected and whatever's pulsing in the center. This explosion communicated with its environment, not metaphorically, physically, materially. The outer medium adapted as the shockwave passed. Instead of being torn apart, much of it rearranged, as though preparing for something else to follow. That's not destruction. That's construction. You begin to wonder, what if stars have life cycles we've barely scratched? What if red supergiants don't just die, they mutate? What if this isn't the endpoint, but the midpoint? Some theorists are beginning to whisper about the stellar chrysalis, the idea that under specific conditions, the collapse of a massive star might lead not to death, but to transition, that the sheer pressure and density of the dying core could induce a new phase of matter, something stable yet undetectable by current means, something halfway between mass and energy, something reactive. In this model, Betelgeuse didn't simply end. It folded inward, wrapped itself in space-time, hid from detection, entered a suspended state, capable of influencing its surroundings in ways we haven't imagined. A cosmic womb. The implications are devastating and exhilarating. Because if Betelgeuse really did create a transitional object, a form of post-stellar evolution, we're not just rewriting textbooks. We're unlocking an entirely new chapter in the life of the universe. It means we don't know how stars die. Worse, it means we don't know what's born when they do. It means we've been watching stellar corpses for 100 years and mistaking them for gravestones, when they might be gateways. And maybe that's why the data is so hard to interpret. Because our language isn't ready. Because our instruments are tuned to catch death, not transition. But the James Webb Space Telescope didn't blink. It didn't flinch. It caught it all. The ripple, the roar, the magnetic unraveling, the light folding in on itself, the dust dancing like it was choreographed. This wasn't entropy. This was design. Whether by physical law, by chance, or by forces yet unnamed. Betelgeuse didn't go quietly. It transformed. And whatever it's becoming, it's not silent. It's not passive. And it's not over. In the months since, JWST has continued to monitor the remnant. The pulses haven't stopped. In fact, they're stabilizing, synchronizing. One astrophysicist compared it to a heartbeat, a rhythm emerging from chaos. That's not poetic. That's terrifying. Because if this object has rhythm, it has regulation. If it has regulation, it has structure. And if it has structure, it might have feedback, meaning it could evolve. Right now, right in front of us. This isn't about danger. There's no threat to Earth, no radiation burst coming our way, no gamma-ray death beam. But the psychological threat, the existential one, that's here. Because Betelgeuse just reminded us that the universe is still writing itself, still composing mysteries at a scale we can barely glimpse, let alone grasp. This is not just a new object in space. This is a challenge, a gauntlet thrown at the feet of our understanding. Betelgeuse was supposed to go supernova. Instead, it became a message. And the message is clear. You do not know what stars can become. And if that's true, if stars don't end, then neither do the stories they leave behind. So now we're left staring into the eyes of a stellar ghost, a cosmic riddle pulsing in the dark, trying to make sense of what Betelgeuse has become. Because what the James Webb Space Telescope delivered was not closure. It wasn't the dramatic death scene we'd spent decades anticipating. It was a breach, a fracture in everything we thought we knew about how stars die and what comes after. Betelgeuse isn't gone. It's different. The models all failed. The simulations were thrown into disarray. Our predictions based on density, mass, age, luminosity, none of them could account for what's unfolding now. Instead of a clean collapse in an expanding shell of superheated gas, we have a sustained phenomenon, a remnant that pulses, a dust field that doesn't drift but reacts, a supernova that refuses to scatter, as if holding itself together for reasons we don't understand. It's not over. And the longer we look, the more it looks like a transformation in progress. Not an explosion, not a death, but a phase change in stellar identity. The star is becoming. Now, we have a new object in the sky. Not a star, not a black hole, not a neutron star. Something else. A cosmic chrysalis. And like all cocoons, what it contains is still hidden, still unfolding, still waiting. The James Webb Telescope has handed us the first chapter. What comes next depends on how far we're willing to look and how much we're willing to let go. Of old ideas, of old models, of the illusion that we've figured this universe out. Because Betelgeuse just proved something we forgot. The universe is not finished with us. Not by a long shot.